I know you've seen this a lot, so but see what you can remember. For each subatomic particle, the things that make up the atoms, we're going to talk about its charge, its mass, and where it is. For the charge, it's positive or negative or neutral. For the mass, really I want to know which one has almost no mass compared to the other two. And for where it is, I want to know inside the nucleus or outside the nucleus. What's the charge of an electron? Most people know that's negative. And we're going to put a number to it. We're going to call it -1. What about a proton? That sounds positive. It's positive. We're going to call it +1. And then neutron, that sounds neutral. What number would we use for neutral? Very good. Of the three, which one has almost no mass compared to the other two? It does have mass, but compared to the other two, not much. The electron has almost no mass compared to the other two. The other two are about 1 AMU. An AMU is an atomic mass unit. Which one of the particles is outside the nucleus? Okay, so protons and neutrons are in the nucleus, the electrons are outside the nucleus. There's a couple things we can do with this. First of all, I could ask, where is most of the mass located in the atom? Most of the mass is in the nucleus. Protons and neutrons are in the nucleus, that's where most of the mass is. Another thing I could ask is, what is the overall charge of the nucleus? The nucleus has the protons and neutrons, so it's positive. It's helpful to remember that the protons and neutrons are in the nucleus and they have all the mass, because we'll talk about the mass number in a minute, and that comes from protons and neutrons. Okay. Also, I want you to have an idea of the scale of this, that an atom is actually a very, very small nucleus in a very large area where the electrons are. So the nucleus is pretty small compared to the overall size of an atom. I'm going to show you a couple of experiments that led to an understanding or discovery of some of the particles. I don't go into as much detail as some instructors do on this, but I do like to hit two famous experiments or setups. In this one, J.J. Thomson discovered and determined some properties of the electrons. So charge plates, using a battery, this is a battery, there's a charge plate, a negative plate, and a positive plate. And so it was found that there seemed to be some kind of particle that traveled from the negative toward the positive plate. So by putting this little hole in here, those charged particles would just go on through. And so these charged particles, sometimes called a cathode ray, a stream of electrons, if they went through between these two plates, so here's another charged plate, negative and positive, these particles tended to bend or veer toward the positive one, which tells you that the particles are negative. So the cathode ray was made up by a special type of particles that was named the electron. So I'll say they're charged particles coming from the atom, the electrons. Let's look at another experiment. This has to do with the nucleus, the Rutherford gold foil experiment. In this experiment, there is a lead block that's to block radiation, except for in one little hole in the front. In here is the radioactive material that releases alpha particles. And so by having this one little hole, we get a stream of alpha particles coming out. Here's another lead plate to kind of make sure that there's just a fine stream of these particles coming out. Ideally, kind of one at a time or close to that anyway, not too many. And so here's the piece of metal foil, like gold foil. It's very thin piece of foil. What you might expect is that the atoms are pretty solid, and so all of these flying particles would bounce kind of straight back. But that's not what was observed. Most of the alpha particles went pretty much straight through. They may have been off by a little bit of angle. Every now and then there was one that got bounced back at an angle like so. So this told you something about the nucleus, because the nucleus is where all the mass is located, and it tells you that the atom is not totally solid. Let's see how this worked. So here's the alpha particles coming in, and you can see, like this one, that as it comes through, it doesn't hit a nucleus. Most of the outside of the atom is empty space. The nucleus has all the mass, or most of the mass, and it's very small compared to the size of the atom. Look at these over here. So most of the mass is in the nucleus. The nucleus is positively charged, and that's based on the alpha particles being positively charged and how well they got repelled. There were a lot of calculations involved in all of this, of course. The nucleus is very small compared to the overall atom size.